Yesterday, we have discussed about the parametric tests. Out of the parametric tests, we classified them into two categories or two families, t-test and ANOVA. In the t-test family, we had three tests. That is, one sample t-test, independent samples t-test, and paired samples t-test. In the case of ANOVA, we had discussed about two types of ANOVA, one-way ANOVA and two-way ANOVA. I hope that you all would have learned at least something from the yesterday's discussion. In the t-test category, first one sample t-test. The second one is there no. What is it? The second one is independent samples t-test. While discussing about the independent samples t-test, I told you certain conditions. That is, in the case of one sample t-test, one sample, one data, dependent variable is scale data. In the case of independent samples t-test, two samples, one data, dependent variable is scale data. In the case of paired samples t-test, I told you no. There is only one sample, but two data. Data pertaining to the same sample for two different periods. That is a paired samples t-test conditions. Okay. Now in the case of non-parametric tests, we have 5 more tests here. We are going to discuss 5 tests coming under the category of non-parametric tests. Number 1, Mann-Whitney U-test. Mann-Whitney U-test. Number 2, Kruskal-Wallis test. Number 2, Kruskal-Wallis test. Number 3, Wilcoxon test. Number 3, Wilcoxon test. Number 4, Fredman test. Fourth one, Fredman test. And the last one we are going to discuss today is chi-square test. That's all. So number 1, Mann-Whitney U-test. Number 2, Kruskal-Wallis test. Number 3, Wilcoxon test. Number 4, Fredman test. And the last one is chi-square test. Okay. See, there is a similarity and a difference between two tests. In the case of parametric tests, t-test and ANOVA were there. In t-test, one sample t-test, independent samples t-test, and paired samples t-test. Take the second one, independent samples t-test. What were the conditions? There should be one sample. There should be two samples. There should be two samples that are independent. Independent means mutually exclusive. We discussed about the VOLA and fast track. VOLA and fast track. Look at this. Let me show it once again for your understanding. See, this is the problem we discussed about the independent samples t-test. Here, this is name of the cab operator. And this is the number of journeys booked. This is the samples. This is the data. So there is only one data. There are two operators, Ola and Fast Track. Ola and Fast Track. See, these are mutually exclusive. An Ola operator cannot be regarded as a Fast Track operator also. If it is Ola, then Ola only. It cannot be regarded as Fast Track. So they are independent. They are independent. So there are two samples, Ola and Fast Track. Then the dependent variable, number of journeys booked, real values are given. So it is a scale data. Look at the Mann-Whitney U-test. This is the problem I have given to you for Mann-Whitney U-test. Look at this. There is a company. The company has some 30 employees, and they are categorized on the basis of nature of job. Their performance level is measured based on the nature of job. The employees are divided into managerial and technical. So there are two samples, two categories of respondents. Based on the nature of job, there are two categories of employees. So it is similar. It is similar to the independent sample t-test. Whereas you come to the dependent variable. In the case of independent sample t-test, the dependent variable was given as scale data. The real values were given. Number of journeys booked, 125, 225, 178, like that. We had some real values. But here, the performance level is given as the dependent variable. Performance level is not given as real value. So it is not a scale data in this problem. Here, it is given as a scale, that is ordinal data. Excellent, very good, good, fair, and poor, like that. The performance level is given as grades. Instead of real values, it is given as grades. So that is the difference between independent samples t-test and Mann-Whitney U-test. There is a similarity between independent samples t-test and Mann-Whitney U-test. What is the similarity? Data, I mean the employees or the samples are divided into two categories. Earlier, in that case, Ola and Fast Track. So there were two categories. Here, there are two categories, that is managerial and technical. So that is the similarity. Difference between these two tests are, in the previous case, we were given the real values, that is scale data was given. But here, ordinal data is given. So there is a relationship between independent samples t-test and Mann-Whitney U-test. So the purpose of independent samples t-test and Mann-Whitney U-test is one and the same, but it varies with reference to the dependent variable. That is why we call Mann-Whitney U-test as a non-parametric equivalent to independent samples t-test. It is the non-parametric equivalent to the independent samples t-test. Why? The purpose of both the tests are same. Number of categories, 2 only. Only difference is with reference to data. Earlier, if the data is given as scale data, you can apply independent sample t-test. If the data is given as ordinal data, then you can apply Mann-Whitney U-test. That's all. So that is the difference between these two tests. So you can decide easily whether independent sample t-test is to be applied or Mann-Whitney U-test is to be applied. Based on the literature, similar nature of studies, which test was used, based on that you can select the test. And regarding the data, if the data is available or you have collected the data in the form of scale data, you can apply independent sample t-test. Or if you have collected data in the form of ordinal data, you can apply Mann-Whitney U-test. Even before collection of data, you can decide the tool whether you want to apply independent sample t-test or Mann-Whitney U-test. If you are particular about applying Mann-Whitney U-test, then you have to construct the questionnaire like this. So the performance level must be measured in terms of grades. It is ordinal data. Here it is given as ordinal data. So managerial, technical are the two categories. Performance level, excellent, very good, good, fair and poor are the grades. Now question, you are required to examine whether there is any significant difference in the level of performance of managerial and technical employees. So as usual, we have to formulate the hypothesis. Null hypothesis, there is no significant difference in the performance level of managerial and technical employees. Alternative hypothesis, there is a significant difference between the performance levels of managerial and technical employees. So this is what we have to do at first. At the beginning, we have to write the hypothesis. Now let us see how to apply the test. See, this is the data I have given to you. Based on the data, we shall apply the tool. For applying the parametric test, we go to analyze and compare means. That is used for one sample t-test, independent sample t-test, paired samples t-test, and one-way ANOVA. The next menu, general linear model, was used to apply two-way ANOVA. Now, for applying non-parametric tests, you go down. Non-parametric tests. Here you go to the legacy dialogues. If you select the legacy dialogues, then on the right hand side, one more drop down menu appears. Look at this, chi-square, one sample KS test, two independent samples t-test. Two independent samples test. That is what we have to apply because there are only two independent samples, managerial employees and technical employees. Since the data is given as ordinal data, we are applying this test. If it is a scale data, we can straight away go to the independent sample street test. So let me repeat the procedure once again. Analyze, non-parametric tests, legacy dialects, two independent samples test. If you click that, a window will be appearing like this. Here, first of all, we have to select the test variable. Look at the variables list. What we have to select? What? Sorry, performance level. Performance level is the test variable. As usual, grouping variable. What is the grouping variable? Nature of job. Nature of job. Nature of job is the grouping variable because see here in the problem, nature of job is given, performance level is given. We are going to test the performance level. So test variable is performance level and grouping variable is nature of job. So we have to define groups. How many groups are there? Only two groups. So group 1, 1, group 2, 2. Then click continue. See, Mann-Whitney U test is selected in default. So you just click OK. So these are the results of Mann-Whitney U test. There are two tables as usual. First table, it contains descriptive data. In the case of independent sample street test, we got number, that is frequency, then mean, then standard deviation. But here we get frequency, mean rank, not mean. Earlier, independent sample street test, we get mean and standard deviation. Here we are getting mean rank and sum of ranks. Then the test results, Mann-Whitney parameter is given, value is given, Wilcoxon value is given, Z value is given, P value is given, then exact significant value is given. Out of all these measures, Mann-Whitney, Wilcoxon, Z, P value, exact significant value, of all these measures, we have to take the P value alone. As usual, P value is the deciding factor. Even though there are number of measures given, Mann-Whitney measure is given, Wilcoxon measure is given, Z score is given, P value is given, and exact significant value is given, we have to take the P value as the significant value or deciding factor. So what is the P value here? P value is 0.019. 0.019. What is the level of significance? 5%. Level of significance, 5%. That means 0.05. We are testing, we are checking whether the P value is less than 0.05 or not. Yes, the P value is less than 0.05. If the P value is less than 0.05, there is a lesser possibility of accepting the null hypothesis. So we have to reject the null hypothesis. We have to reject the null hypothesis. If the null hypothesis is rejected, we have to select the alternative hypothesis. Or we have to accept the alternative hypothesis. What is the alternative hypothesis here? there is a significant difference in the performance level of managerial and technical employees. So the performance levels of managerial and technical employees are significantly different. That is what we have concluded. It is concluded that the performance level of managerial and technical employees is significantly different. Earlier, in the case of independent sample status, we further tested which cab operator has got more bookings, whether Ola or Fast Track. For that, we compared the mean values. We compared the mean values. If the mean values are compared, the highest will be the better one. Highest will be the better one. But if ranks are compared, so for example, A has got 80 marks, B has got 90 marks. A has got 80 marks and B has got 90 marks. So who is better, A or B? A 80 marks, B 90 marks. So obviously B will be the better student than A. Okay. Suppose A got the first rank and B got the second rank. A got the first rank and B got the second rank. Now who is better? A is better than B. When marks are given, the student who got more marks was considered as better candidate. When ranks are given, the student who has got lower rank is considered better. Based on that logic, here we are given mean ranks of managerial and technical employees. So what is the mean rank of managerial employees? It is 20.32. What is the mean rank of technical employees? It is 12.71. 12.71. So what can we conclude? Technical employees got the lower mean rank. So obviously their performance is better than the managerial employees. Their performance is better than the managerial employees. That is what we can conclude. If suppose it is mean value instead of mean rank, if this is given as mean values like in the independent sample test, the higher score will be considered as the better one. But here, since the mean ranks are given, we draw the conclusion based on the lower rank. So here, mean rank of technical employees is lesser or lower than the mean rank of managerial employees. So we can further conclude that the performance level of technical employees is better than the performance level of managerial employees. This is how we have to conclude. So first of all, we got the question. We checked how many samples are there. There are 2 samples. If there are 2 samples, only 2 tests will be coming into our mind. One is independent sample t test and man-Whitney U test. Then based on the dependent variable, whether the dependent variable is scale data or ordinal data. If it is ordinal data, we can apply independent sample street test. If it is scale data, we have to apply independent sample street test. If it is ordinal data, we have to apply the Mann-Whitney U-test. That's all. So this is what about Mann-Whitney U-test. It is considered as the non-parametric equivalent to the independent samples t-test. So both are similar in one aspect and different in another aspect. And the general conditions as usual. Parametric tests can be applied only when the data are normally distributed. But here, whether the data are normally distributed or not normally distributed, you can apply non-parametric tests. So before collecting the data, you are designing your research, you are preparing your research design. At that time itself, you can consider or you can decide which test will be appropriate for your study. Based on the previous literature, you can decide. Or based on the expert opinion, you can decide. Or based on your knowledge, you can decide that this is the test I want to apply for my study. If you want to apply parametric tests, there is a condition that the data should be normally distributed, dependent variable should be the scale data. But here, before that, you can decide whether you want to apply Mann-Whitney U-test or not. If you want to apply Mann-Whitney U-test, you need not bother about the normality of data. You need not bother about the normality of data. Okay. But you have to decide the type of data. The data should be the ordinal data. The data should be ordinal data. So at the time of constructing your questionnaire, you can decide your questionnaire like this. The question should be framed like the ordinal data. That's all. So next one, Kruskal-Wallis test. Next one, Kruskal-Wallis test. Look at the problem. I think the same problem. The independent variable is different. Earlier it was nature of job. Now it is type of employee, skilled, semi-skilled, and unskilled. There are 3 types of employees. If there are only 2 types of employees or 2 categories of employees, we have to apply Mann-Whitney U-test. If more than 2, then we have to apply Kruskal-Wallis test. Earlier, we have discussed about the one-way ANOVA. Look at this. There are 3 categories: Swiggy, Zomato, Uber Foods. There are 3 categories. Data is given as scale data. Dependent variable is scale data. Here, there are 3 categories: skilled, semi-skilled, and unskilled. So it is the similarity between one-way ANOVA and Kruskal-Wallis test. What is the difference? The dependent variable. Earlier, the dependent variable was given as satisfaction score. So it is a scale data. But here it is given as ordinal data. So the similarity is more than two groups. Difference is scale data for one-way ANOVA, ordinal data for Kruskal-Wallis test. So if the data available is scale data, straight away you can go for ANOVA, one-way ANOVA. If the data is available in the form of ordinal data, you have to apply Kruskal-Wallis test. So Kruskal-Wallis test is regarded as non-parametric equivalent to one-way ANOVA. Non-parametric equivalent to one-way ANOVA. So look at the question. You are required to examine whether there is any significant difference in the level of performance of skilled, semi-skilled, and unskilled employees. First of all, we have to formulate the hypothesis. Null hypothesis. There is no significant difference in the performance levels of skilled, semi-skilled, and unskilled employees. What is alternative? There is a significant difference in the performance levels of skilled, semi-skilled, and unskilled employees. That's it. Now, let us go to the analysis. Once again, analyze non-parametric tests, then legacy dialogues. Now you select K independent samples. Here is also the samples are independent. The samples are independent. Why? Skilled, semi-skilled, and unskilled. A skilled employee cannot be regarded as a semi-skilled. Likewise, semi-skilled cannot be regarded as unskilled. So they are mutually exclusive. So we call them as independent samples. So if it is independent, then we have to apply either one-way ANOVA or Kruskal-Wallis test. Now the data is given in the form of ordinal data. We have to apply Kruskal-Wallis test. See here, there are three independent samples. So we have selected K independent. K means any number. So go to analyze, non-parametric tests, legacy dialogues, K independent samples. So we select K independent samples. Once again, the box is similar like Mann-Whitney U-test. Here we take the performance level, but grouping variable will be type of employee. Earlier, when we applied a Mann-Whitney U-test, look at this. Two independent samples we have selected. Here grouping variable, we have selected nature of job. The box here is define groups. The box below the grouping variable is define groups. If you click the define groups, we got group 1 and group 2 because it is two independent samples test. But now we are going for analyze, non-parametric tests, legacy dialogues, K independent samples. K independent samples. That means test for several independent samples. Test for several independent samples. What is the test variable? Performance level. So performance level is the test variable. What is the grouping variable? Type of employees. Look at this box. Earlier it was define groups. Now it will be define range. Look at this. Define range. Earlier it was define groups. So group 1, group 2. Now it is define range. If you select that, the windows will be appearing, the sub window will be appearing like this: minimum, max. Earlier it was group 1, group 2 because there were only 2 groups. But here several independent samples are there. So what is minimum? What is maximum? How many samples are there? We have 3 samples. So minimum 1, maximum 3. Suppose if we have 4, then we can select, we can enter 1 for minimum and 4 for maximum. Then go to continue. Look at this, Kruskal-Wallis test is selected in default. So nothing needs to be done. Straight away you can click OK. So these are the results. These are the results. Let me come to the Word document. See here. First table contains, as usual, descriptive. Second one, test results. Earlier, you know, Mann-Whitney measure was given, Wilcoxon measure was given, Z score was given, p-value was given, then exact p-value was given in the case of Mann-Whitney test. But here, chi-square value is given, degrees of freedom is given, p-value is given. See, chi-square is a common measure that is used in most of the non-parametric tests. But we don't bother about chi-square test, chi-square value. Degrees of freedom is also not considered. So what is considered here? We consider the p-value. What is the p-value here? P-value is 0.911. 0.911. What is the significant level? 5%. That is 0.05. We have to check whether the p-value is less than 0.05 or greater than 0.05. Here, the p-value is greater than 0.05. That means the possibility of accepting the null hypothesis is more. So we have to accept the null hypothesis. What is the null hypothesis? There is no significant difference in the performance level of skilled, semi-skilled, and unskilled employees. So we conclude that there is no significant difference. There is no significant difference in the performance level of skilled, semi-skilled, and unskilled employees. So what is the conclusion? It is concluded that the performance level of different types of employees is not significantly different. But look at this. Mean rank. Unskilled 14.86, semi-skilled 15.36, and skilled 16.56. Even though we have concluded that there is no significant difference in the performance level, there is no significant difference in the performance level, there could be some difference at least. So here we consider 3 types of employees, earlier 2 types of employees. So comparative degree we used. Who is better? If there are only 2 categories, we considered who is better. Comparative degree. Here we have 3 groups, more than 2. So we are using superlative degree. So who is the best one? Who is the best one? If it is mean score, then we can say skilled employees are the best one. But since it is given as mean rank, the lowest will be considered as the best performing category. So here 14.86 for unskilled, 15.36 for semi-skilled, and 16.56 for skilled. So which is the lowest? The lowest is unskilled. The lowest is unskilled. So we can say that the unskilled employees have given the best performance in the company than the skilled employees and semi-skilled employees. So this is what about the Kruskal-Wallis test. The difference between Kruskal-Wallis test and one-way ANOVA is the data. If the data is given as scale data, we have to apply one-way ANOVA. If the data is given as ordinal data, we have to apply Kruskal-Wallis test. So here also, at the time of drafting your questionnaire, you can decide. See, suppose you are assigning scores, performance scores are assigned, then it is scale data. If performance grades are given, it is ordinal data. You can decide which test is to be applied for your study. If suppose you are particular about applying Kruskal-Wallis test, then you can structure your questionnaire using the grades, using the ordinal data. That's all. This is about Kruskal-Wallis test. So next we shall move on to the Wilcoxon test. This is the third type of test. Wilcoxon test. Simply by seeing the data, you can say it is similar to the paired t-test, because before, after. So one sample is there, no differentiation, no categorization, all are considered as one sample, but the data are obtained for two different periods. Earlier, in the case of paired samples t-test, look at this. Monthly average grocery purchase before lockdown and after lockdown. Only one sample, no categorization. Family 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. But the data was given as scale data. Real values were given. But here, what is the similarity? There is only one sample. There is only one sample. What is the difference? The data is given as ordinal, neutral, highly satisfied, satisfied, neutral, dissatisfied, and highly dissatisfied. Here also two data, one sample, two data. One sample, one data means one sample t-test. Two samples, one data means independent sample t-test. One sample, two data means paired sample t-test. The same here. Two samples, one data means Mann-Whitney test. One sample, two data means Wilcoxon test. That's all. So here, the data are given as grades. You are required to examine whether there is any significant difference in the level of satisfaction of drivers or owners of the vehicles after implementation of FAST Track. The FAST Track is implemented. So we are not required to wait in a long queue at the toll plaza. Our FAST Track sticker is scanned and amount is deducted. We don't need to tender exact change at the toll plaza counter. We need not bother about the currency notes. because it is automatically deducted from your account. So the time consumed is reduced after implementation of FASTag. So here we are required to examine whether there is any significant difference in the level of satisfaction of drivers or owners of vehicles after implementation of FASTag. So obviously, the hypothesis will be there is a null hypothesis. There is no significant difference in the level of satisfaction of drivers or owners of vehicles before and after implementation of FASTag. Alternative hypothesis. There is a significant difference in the level of satisfaction of drivers or owners of the vehicles before and after implementation of FASTag. That's all. So here, there is a similarity between paired sample street test and Wilcoxon test. That is, number of samples is 2. I mean, number of samples is 1 and number of data is 2. But the difference is, earlier the data was scale data, now the data is ordinal data. So we consider, or we call the Wilcoxon test as the non-parametric equivalent to the paired sample street test. That's all. So what is the non-parametric equivalent to the independent sample street test? Man-Whitney U test. What is the non-parametric equivalent to one-way ANOVA? Kruskal-Wallis test. What is the non-parametric equivalent to the paired sample street test? Wilcoxon test. So 3 tests of non-parametric category are compared and contrasted or linked with the 3 similar categories of parametric tests. So parametric test, independent sample street test. Non-parametric test, Man-Whitney U test. One-way ANOVA, Kruskal-Wallis test. Paired sample street test, Wilcoxon test. These things you have to keep in mind. Similarity is about the number of samples. Number of samples and number of data. Similarity is with reference to number of samples and number of data. In the case of independent sample street test and Man-Whitney U test, number of samples is 2. Number of data is 1. In the case of one-way ANOVA and Kruskal-Wallis test, number of samples is more than 2. Number of data is 1. Number of data is 1. In the case of paired sample street test and Wilcoxon test, number of samples is 1. Number of data is 2. That's all. What is the difference between Man-Whitney U test and the independent sample street test or Kruskal-Wallis test and one-way ANOVA or Wilcoxon test and paired sample street test? In the case of these non-parametric tests, the data is ordinal data. In the case of parametric tests, the data is scale data. That's all. Now we shall go to the analysis. Once again, go to analyze, non-parametric tests, legacy dialogues. Now, 2 related samples. Now, 2 related samples. Because how many samples are there? Only 2. I mean, how many data are there? 2. That is before and after. So they are related samples. Sample is only 1, but since the data, number of data is 2, we call it as related samples. Earlier it was called as 2 independent samples. Now it is called as 2 related samples. So we select the 2 related samples. Window is appearing like this. you have to select level of satisfaction. Level of satisfaction before FASTag. Level of satisfaction after FASTag. Wilcoxon test is selected in default. Click OK. Repeat. Analyze. Non-parametric tests. Legacy dialogues. 2 related samples. What are the related samples here? Satisfaction before FASTag and satisfaction after FASTag. Click OK. So these are the results. Let me come to the Word document for easy understanding. Here also 2 tables are given, right? 2 tables of output are given. Here Z value and P value. Earlier chi-square, degrees of freedom and P value. Now Z value and P value. We take the P value. Excuse me. We take the P value as usual. What is the P value here? 0.000. P value is 0.000. Now let us check whether the P value is less than 0.05 or not. Yes, it is less than 0.05. Of course, it is less than 0.01 because the P value is 0.000. 0.000. It is less than 0.05 as well as less than 0.01. So what decision we can take? If P value is less than 0.05, the chance of accepting null hypothesis is less. So we reject the null hypothesis. What is the null hypothesis? There is no significant difference in the satisfaction. Automatically, alternative hypothesis is accepted. If alternative hypothesis is accepted, what does it mean? There is a significant difference. Okay. So we conclude that the level of satisfaction of, see here, the level of satisfaction of drivers and owners of vehicles before and after the implementation of FASTag is significantly different. But what is the question? Whether there is a significant difference in the level of satisfaction after implementation of FASTag. So after implementation of FASTag, whether they have got more satisfaction or not. That is the question. For that, here, instead of comparing the mean ranks, in the previous 2 tests, we compared the mean ranks. But here, we should not compare the mean rank. Rather, we have to check this. Because earlier it was not given like this. Here, negative ranks, positive ranks, and tied ranks. Negative ranks, positive ranks, and tied ranks. What do you mean by negative rank? Level of satisfaction after implementation of FASTag is less than the level of satisfaction before implementation of FASTag. It is negative. What is positive? Level of satisfaction after implementation of FASTag is greater is greater than the level of satisfaction before the implementation of fast. Then what is the third one? Tied ranks. If the level of satisfaction after implementation is equal to level of satisfaction before implementation. Okay. How can we decide whether it is less than, greater than, or equal? See here, data is given like this. See, we have ordered like highly satisfied, satisfied, neutral, dissatisfied, and highly dissatisfied. For that, we have assigned scores. We have assigned scores. 5 for highly satisfied, 4 for satisfied, 4 for satisfied, 3 for neutral, 2 for dissatisfied, and 1 for highly dissatisfied. Suppose for this driver, the satisfaction before FASTag was neutral. So what is the value to be assigned? 3. We assign 3. Okay. Then after implementation of FASTag, he is satisfied. So the score is 4. The score is 4. What is asked here? Before, after is greater than before. After is less than before means negative. After is less than before. See what is after? 4. What is before? 3. So after score is greater than before score. After implementation of FASTag, the score is 4. Before implementation of FASTag, the score is 3. So after score is greater than before score. If after score is greater than, see here, after score is greater than before score, it is considered as positive rank. Okay. Then see here. See here. For the 11th driver, the satisfaction level is highly satisfied. So we take 5. We assign 5. But after implementation, this level is just satisfied. So the value is 4. Value is 4. So after value is less than the before value. It is called as negative rank. It is called as negative rank. If after score is greater than the before score, it is called as positive rank. If after score is less than before score, look at this. After score is less than before score. See here. After score is less than before score, it is negative. If after score is greater than before score, it is positive. Suppose, see, look at here. The same level is maintained. If the same level is maintained, for which driver? See here. Fifth one. Before implementation, highly satisfied. So 5. After implementation also, highly satisfied 5. So both are equal. Equal means tied rank. Equal means tied rank. So here, number of negative ranks 3, number of positive ranks 24, number of tied ranks 3. That means, once again, you come to the description. Negative rank means satisfaction after implementation is less than satisfaction before implementation. That means after implementation, the satisfaction is reduced. After implementation, the satisfaction is reduced. In the case of 3 drivers. In the case of 3 drivers. What about positive rank? Satisfaction after implementation is greater than satisfaction before implementation. That means the satisfaction level is increased after implementation in the case of 24 drivers. In the case of 3 drivers, the level is same. The satisfaction level after implementation is equal to the satisfaction level before implementation of FASTag. Okay. Now look at the numbers. Number of negative ranks 3. Number of positive ranks 24. Number of tied ranks 3. So which is the greatest? 24 is the greatest. So positive ranks. There are more positive ranks than negative ranks or tied ranks. If negative ranks are more, then we can say the satisfaction level after implementation of FASTag is reduced. That means they are not satisfied with the FASTag. They are not satisfied with FASTag. If tied ranks are more, we can say, see, even before it is like that, even after that it is like that only. There is no, I feel no difference before implementation and after implementation. Even if the FASTag is implemented, sometimes we are waiting in long queue. Then what is the use of implementation of FASTag? Only thing is, we need not enter the exact change. Otherwise, the main idea behind the implementation of FASTag is to save the time, to reduce the consumption of time. But here, even though it is a FASTag is implemented, sometimes the scanner or camera is not working. We have to wait for a long queue in a particular track, and we are not able to shift to another rack because behind our vehicle there may be a lot of vehicles waiting. So shifting to another rack is not possible. So we have to wait until the camera is ready or until the scanner is ready. So I don't feel that it is good or that it is better than the before implementation of FASTag. I feel similarly that is said to be tied rank. But positivity after implementation of FASTag, my level of satisfaction is improved. Then obviously we can say that the implementation of FASTag is successful in improving the satisfaction of drivers. Not only that, the very purpose of implementation of FASTag is to reduce the consumption of time, reduce the waiting time in the toll plaza. So it is obviously proved, because out of 30 drivers, 24 drivers said their satisfaction level is increased after implementation of FAST. So that is what conclude. So the conclusion is the level of satisfaction of drivers before and after implementation varied significantly. So after implementation of FASTag, the satisfaction of drivers is increased. That's all. So this is about the Wilcoxon test. So there are three pairs we have compared: parametric and non-parametric, independent sample street test and man-weight NIU test, one-way ANOVA and Kruskal-Wallis, paired sample street test and Wilcoxon test. That's all. The next one is somehow different, Friedman test. See, nowadays we are using digital payment methods. We are using banking cards, mobile banking, USSD, UPI, mobile wallets are also used. Sometimes prepaid cards are issued by banks. At the time of purchase of goods, we are sweeping the cards at the point of sale device. Then sometimes using the Aadhaar card itself, you can transfer the funds or withdraw funds from your bank account without the use of your banking cards. Simply by using the Aadhaar card, you can withdraw funds. So that is said to be AEPS. Then internet banking, that is quite popular. Then micro ATMs in villages where there is no ATM, where there is no on-site ATM or off-site ATM. This kind of micro ATMs are available in order to render services to the village people or rural customers. So these are the different types of or different methods of digital payments. Now the customers are asked to rank these digital payment methods according to you, which is the first preferred digital payment method. See here, the first customer said point of sale is the first one. Second customer said USSD is the first one. Third one said mobile banking is the first one. Fourth one also ranked the mobile banking as the first one. Fifth one also has ranked the mobile banking as the first one. Sixth one ranked USSD as the first one. Seventh one again mobile banking. Eighth one again mobile banking. Ninth one again mobile banking. Like that, the ranks are assigned. Okay. There are 30 customers. Here, in the case of Wilcoxon test, two related samples, before and after. But here, we are given 10 data. We are given 10 data. Earlier, 2 data. One sample, 2 data. Here, one sample, 10 data. So we call it as K-related samples. We call it as K-related samples. Now come to the question. You are required to examine whether there is any significant difference in the ranking of digital payment methods by customers. Okay, right. You have to check this. For that, as usual, we are framing the we are formulating the hypothesis. Null hypothesis. There is no significant difference in the ranking of digital payment methods by the customers. Alternative hypothesis. There is a significant difference in the ranking of digital payment methods by the customers. Now go to the analysis. Analyze non-parametric tests, legacy dialogues, care-related samples. Last one. So test for several related samples. Only thing is test variables, no grouping variable. You select all the 10 items. Banking cards, mobile wallets, micro ATMs. Either you can select all and use the right arrow, or otherwise you can drag one by one, or you can select one by one. See, if Redman test is selected in D2, click OK. Let me repeat once again. Analyze, non-parametric tests, legacy dialogues, care-related samples. See here, we are selecting all the digital payment methods at once, or each one may be selected like this. Okay. Then click OK. Once again, we got two tables. See here. N, chi-square, degrees of freedom, again p-value. Degrees of freedom and p-value. What is the p-value? 0.002. What is the level of significance? 0.05. You have to check whether the p-value is less than 0.05. Yes, it is less than 0.05. Since it is 0.002, we can say that it is less than 0.01. It is less than 0.01. So if it is less than 0.01, there is very less possibility to accept the null hypothesis. If the possibility is very less, then you can reject. If the null hypothesis is rejected, alternative hypothesis is accepted. So what is the alternative hypothesis? There is a significant difference in the ranking of digital payment methods by customers. Since the p-value is less than 0.01, there is a significant difference in the ranking of digital payment methods by the customers. Now you come to the first table. Again, mean rank. So banking cards, mobile wallets, USSD, USSD, then UPI, mobile banking, banks prepaid cards, point of sale, Aadhaar enabled payment system, internet banking. I think this is mobile wallets. You just change this in and this is mobile banking. Just look at the data. Yeah, see here, first one is mobile banking cards, second one is mobile wallets. Second one is mobile wallets. So you please change the data like this. First one banking cards, second one mobile wallets. Then this one is banking, mobile banking. Now You come to the first table. You check the mean ranks. Mean rank of banking cards 5.07, mobile wallets 4.20, then USSD 5.30, UPI 5.83, mobile banking 4.70, bank prepaid cards 4.70, point of sale 5.77, Aadhaar enabled payment system 5.83, banking, internet banking 6.07, and micro ATMs 7.53. So once again, since we are comparing the mean ranks, not the mean scores, we have to select the lowest mean rank. Which digital payment method has the lowest mean rank? Look at this 5.07, 5.30, 5.83, 4.70. So 4.20 is the lowest. It belongs to mobile wallets. Mobile wallets. So conclusion. It is concluded that customers have ranked the digital payments in a significantly different manner. Because of p-value, we concluded like that. Then out of the 10 digital payment methods, mobile wallets have the lowest mean rank. So it's further concluded that mobile wallet has been the most preferred or most attractive method of digital payments. That's all. Okay. So this is what about Friedman test. The difference between Wilcoxon and Friedman test is number of data. If number of data is 2, we have to apply 2 related samples. That is Wilcoxon test. If the data is more than 2, then we have to select the Friedman test. So once again, there is a comparison between some tests. See here, Mann-Whitney 2 test, Mann-Whitney U test is called as 2 independent samples test. Kruskal-Wallis test is called in another way as K independent samples. Then Wilcoxon 2 related, Friedman test K related samples. So like the parametric test, in the case of parametric test, we divided the parametric test like t-test and ANOVA. T-test was further divided as one sample t-test, independent samples t-test, and paired samples t-test. One way ANOVA and 2 way ANOVA. Like that, here, non-parametric tests, independent samples t-test and related samples test. Independent samples test and related samples test. Independent samples test is further divided into 2 independent sample test and K independent sample test. Related samples test is further divided into 2 related samples and K related samples. In the case of 2 independent samples, we have to apply Mann-Whitney test. In the case of K independent samples, we are applying Kruskal-Wallis test. In the case of 2 related samples, we are using Wilcoxon test. In the case of K related samples, we are using Friedman test. That's all. So one more test is to be discussed. It is chi-square test. Yes. Some scholars may have a doubt in pronouncing. How to pronounce this? Whether it is chi-square test or chi-square test or chi-square test. Don't bother, it is chi-square test. In what way it is different from the Mann-Whitney U test? See here, there are two samples, attended, not attended. Level of productivity, high, medium, low. It is ordinal data. Earlier in the case of man-Whitney U test also, we had data like this. Managerial and technical. Performance level, ordinal data. Maybe 3-point scale or 5-point scale, that is different. But here, see, it was managerial and technical. Here, attended, not attended. Attended, not attended. The company wanted to increase the level of productivity of employees. For that, the company has conducted a training program. The company has asked the employees to attend the training program. Some employees have attended the training program. Some other employees have not attended the training program. There are 30 employees. 30 employees. Some of the employees have attended, some of the employees have not attended. So there are only 2 samples. Earlier it was managerial, technical. Here it is attended, not attended. The chi-square test is to be applied to test the goodness of fit. To test the goodness of fit. That means, suppose, another example, let me tell you. We were suffering from COVID-19 in the year 2020, 2021, and early part of 2022. Earlier, we had no vaccination. After that, vaccination was introduced. Somebody has taken vaccination, somebody has not taken vaccination. Even if vaccination is taken, somebody might have been affected by COVID-19. If vaccination is taken, somebody may not have been affected. Out of those who have not taken vaccinated, somebody might have been affected, somebody might not have been affected. So the test is whether the vaccination, like Covaxin and Covishield, we have taken no first dose, second dose, like that. So whether the Covaxin or Covishield is good or it is fit for the controlling of COVID-19. So there are certain possibilities. Vaccination taken, not taken. Affected, not affected. That kind of 2x2 table. We call it as 2x2 contingency table. Affected, vaccinated, not vaccinated. Affected, not affected. So vaccinated, affected, vaccinated, not affected. Not vaccinated, affected, not vaccinated, not affected. So 4 quadrants, 2x2 table. Likewise here, affected, attended, not attended. Attended, not attended. Instead of affected, not affected, we are categorizing into 3. 3 grades are given: high, medium, low. High, medium, low. In the case of man-Whitney U test, the samples were divided as managerial and technical. But here, attended, not attended. The purpose of conducting this training program is to increase the productivity, In the man-weight test, we compared the performance of managerial and technical. There was no training program. There was no vaccination. There was no specialized program. But here, a program is conducted, like this workshop is conducted to increase our knowledge about the tools. This 2-day workshop is conducted. So somebody might have attended, somebody might not have attended. After attending this workshop, whether you feel that your knowledge is improved after attending the program or not. So attended, not attended. Improved, not improved. Like that here, attended, not attended. High, medium, low. Originally, as I told you, chi-square test was introduced to test the goodness of it. That was initially used for 2x2 contingency table only. 2x2 means number of rows 2, number of columns 2. But here, number of rows 2, number of columns 3, high, medium, low. So this contingency table will be 2x3. Initially, it was used for 2x2 only, but it is used for 2x3 also now. Okay. So here, what is the question? You are required to examine whether the training program was successful in increasing the productivity. So if the question is asked like that, and the data is given as ordinal data, the samples are divided as attended, not attended, taken, not taken, then we have to apply chi-square test. As usual, we formulate the hypothesis, null hypothesis. There is no significant impact of training program on the level of productivity. Obviously, alternative hypothesis. There is a significant impact of training program on the level of productivity. Now we'll go to the analysis. See here, there is one more debate among the scholars whether chi-square test is a parametric test or non-parametric test. Whether the chi-square test is a parametric test or non-parametric test. You can firmly argue that chi-square test is a non-parametric test only, because here no parameters are used, and if you go to the non-parametric test, you can find the chi-square test here. So it is clearly given under the heading of non-parametric test. So there is no need for debate. There is no need for argument whether chi-square test is a parametric test or non-parametric test. You can strongly argue that it is a non-parametric test. So this is one of the gateways or one of the procedures through which chi-square test can be applied. But unlike the other 4 non-parametric tests like man-Whitney test, Kruskal-Wallis test, Wilcoxon test, and Fredman test, we are not using this gateway. Then what else is to be followed? Analyze, go to descriptive statistics, then go to cross tabs. Go to cross tabs. If you click on that, you can see like that. This is a window appearing after you click analyze. Analyze, go to descriptive statistics, then go to cross tabs. So rows and columns. I told you no. What is the row? Training program is the row variable. What is the column variable? Productivity level is the column variable. That's all. Then 5 buttons are here given. The second button is statistics. If you click on this button, you can find the number of statistics tools. First one, chi-square. It is not selected in default, so you can select manually. Then continue. Then OK. Let me repeat. Analyze, descriptive statistics, cross tabs. Row variable, training program. Column variable, productivity level. Go to statistics button, select chi-square manually, then continue, then click OK. You will get results like this. There are 3 tables. Now come to the bottom. I given only 2 tables. First one is just a case processing summary. So we have not used that. It is just a number of valid cases, number of missing cases, total. All the 30 are valid. So there is no missing cases. That is why I have not shown in the output. Only 2 tables we have considered. First one, as usual, descriptive. Second one, the test result. Here also, we have chi-square value, likelihood ratio, linear by linear association, and number of valid cases. As usual, we have to take the Pearson's chi-square. Pearson's chi-square, p-value. P-value is 0.013. What is the level of satisfaction? Level of satisfaction is 0.05. So we have to check whether the p-value is less than 0.05 or greater than 0.0. It is less than 0.05. If the p-value is less than 0.05, the possibility for accepting null hypothesis is less. If the possibility is less, then reject the null hypothesis. If the null hypothesis is rejected, you can accept the alternative hypothesis. If the alternative hypothesis is accepted, it is concluded that there is a significant impact or the training program is successful in increasing the productivity. That conclusion cannot be made now. Now we can say that there is a significant impact, whether the impact is positive or negative. For that, now we shall look at the first table. Out of 30 employees, 19 employees have attended the training. 11 employees have not attended the training program. Out of these 19, 2 employees have given low productivity. 7 employees have given medium productivity. 10 employees have given high level of productivity. So low productivity level is less. High productivity level is more for the employees who have attended the training. There are 11 employees who have not attended the training program. Out of them, the level of productivity of 6 employees was found to be low. And the productivity level of 4 employees is medium. There is only 1 employee who has given high productivity level. So those who have attended the program have given high productivity level. Those who have not attended have given low productivity level. So automatically we can conclude that the training program was successful in increasing the level of productivity of employees. That's all. So this is about chi-square test. Once again, recap both parametric and non-parametric tests. Parametric tests, when parameters are used, it is said to be parametric test. When parameters are not used, it is said to be non-parametric test. What are the parameters? Mean, standard deviation, and variance. For parametric tests, there are 2 conditions. Number 1, the data should be normally distributed. For the non-parametric test, data may or may not be normally distributed. Second condition, for the parametric test, the data should be scale data. Here, the data is ordinal data. That's all. In the parametric test, there are 2 types, t-test and ANOVA. T-test is divided into 3. One sample t-test, independent samples t-test, and paired samples t-test. ANOVA is divided into 2, one-way ANOVA and two-way ANOVA. In the case of one sample t-test, only one sample and only one data, the data is scale data. In the case of independent samples t-test, there are 2 samples and 1 data, the data is scale data. In the case of paired sample t-test, there is only 1 sample, 2 data. The data is scale data, that's all. In the case of ANOVA, one-way ANOVA, number of samples, more than 2. For two-way ANOVA also, number of samples, more than 2. Here what we understand, if the number of samples is 1 or 2, we have to select t-test. If the number of samples is divided into more than 2 categories, then you have to go to ANOVA. So what is the difference between one-way ANOVA and two-way ANOVA? One-way means only one independent variable. Two-way means 2 or more independent variables. That's all. Again, scale data is compulsory for both of the cases. So one-way ANOVA, more than 2 samples, only one independent variable, data is scale data. In the case of two-way ANOVA, more than 2 more than 2 samples and 2 or more independent variables, data is scale data. This is two-way ANOVA. Then we come to non-parametric tests. This is divided into three: independent samples test, related samples test, and chi-square test. Independent samples divided into two independent samples, k independent samples. Related samples test is divided into two related samples, k related samples. Then two independent sample test is Mann-Whitney U test. K independent samples T test is Kruskal-Wallis test. Two related samples, Wilcoxon test. K related samples, Friedman test. Then similarity or equivalence. Independent samples T test and Mann-Whitney U tests are equivalent. The purpose of these two tests are same. Only one difference. What is the difference? What is the similarity? There are only two samples. There are only two samples. If the data is scale data, we have to apply independent samples T test. If there are two samples and one data is ordinal data, we have to apply Mann-Whitney U test. So Mann-Whitney U test is called as non-parametric equivalent to the independent samples T test. Then come to the another pair, one-way ANOVA and Kruskal-Wallis test. They are similar. In both of the cases, number of samples is more than two. Number of samples is more than two. But in the case of one-way ANOVA, the data is scale data. Here the data is ordinal data. That is the only difference. So Kruskal-Wallis test is called as non-parametric equivalent to the one-way ANOVA. This is one of the pairs. Another pair is also there. That is, we are comparing the paired samples T test and Wilcoxon test. There is a similarity. One sample, two data. One sample and two data. What is the difference? The data is scale data in the case of paired samples T test. In the case of Wilcoxon test, the data is ordinal. That's all. So it is called as two related samples. Wilcoxon test is also called as two related samples test or non-parametric equivalent to the paired samples T test. That's all. Then one more related sample test is there. That is Friedman test. What is the difference between the Wilcoxon test and Friedman test? In the case of Wilcoxon test, number of samples is 2. Here number of samples is more than 2. What is the similarity? Data is ordinal data in both of the cases. Data is ordinal data in both of the cases. So that is said to be Friedman test. Then come to the chi-square test. Last one, chi-square test. In this case, the data is 2, but dichotomous. Yes or no, attended, not attended. Yesterday, one of the participants asked whether the free voice calls have an impact on the utilization of internet or some question was asked. So free voice calls used or not. If your question is like that, use yes, free voice calls given or not, yes or no. In that case, if you collect data like that, you have to apply chi-square test. Yesterday also I told you. If suppose you are comparing the free voice calls as number of calls, up to 200 calls per month, 200 to 400 calls per month, more than 400 calls per month, like that. In that case, it is not dichotomous. It is not dichotomous. And moreover, the level of impact. Suppose if the level of impact is measured as a score, it is a scale data, then you have to go for parametric tests. If you collect the data, like in this case, level of impact, high, medium, low, high, moderate, low, like that, then you have to apply chi-square test. If yes or no question is used, if you have collected data like less than 200 calls, 200 to 400 calls, more than 200 calls. So how many samples are there? 3 samples are there. It is not dichotomous. It is not dichotomous. It is not yes or no. So you have to go for Kruskal-Wallis test. You have to go for Kruskal-Wallis test. Suppose if you have collected the data as a scale data, then you have to go for one-way ANOVA. That's all. So this is what about the Kruskal-Wallis test, Mann-Whitney test, Wilcoxon test, Friedman test, and chi-square test. So I hope that you all would have understood the difference between parametric tests and non-parametric tests, t-test and ANOVA, independent samples test and related samples test, the different types of t-tests, different types of ANOVA, different types of independent samples test, different types of related samples test, where we have to apply a particular test. So with this, I would like to thank the organizers, Dr. Segar and his team, for having given me wonderful opportunity. I thank all the participants for your patient listening for the past 2 hours today and 2 hours yesterday. Thank you very much. Now, if you have any doubts, you can ask me. Let's have 7 more minutes, I think.
Good evening, sir.
Very good evening, sir.
Sir, my doubt is actually chi-square test related, sir.
Yes.
When we collect the data from 5 different cities related to medical representative problems,
Okay.
by using 5-point Likert scale from strongly agree to strongly disagree,
Okay.
can we use chi-square test for comparison of all these 5 cities, sir?
See, you are telling about the dependent variable. What about the independent variable? How you categorize them? You are categorizing them based on cities.
Cities, 5 different cities, sir.
5 cities. Okay. So it is not dichotomous, like attended, not attended. It is not like that. So, in fact, chi-square test should not be applied. Okay. But some statisticians allow you to use the chi-square test. I told you, no, it is initially used for 2x2 contingency table only, and that to test the goodness of it. But in what way they are allowing means, the chi-square test can be used for testing the association of attributes. Association of attributes. In that case, using that rule, you can use the chi-square test. But my suggestion is, if you are using the 5 cities as a category and the levels as the dependent variable, then it is better to use the Kruskal-Wallis test.
Okay, sir. Actually, that already test is conducted, sir, but a small doubt is kept.
No issues. No issues. I told you no.
No, sir.
Initially, it was used for 2x2 only.
No, sir.
Attended, not attended. The main purpose of using chi-square test is to test the goodness of it.
No, sir.
But for testing the association of attributes,
No, sir.
chi-square test is used So there is no problem in applying chi-square test. What you have applied is okay. Don't bother about it. You can justify at the time of 5 hours examination, you can justify that chi-square test is used because of testing the association between attributes. Like that you can argue.
Because of the testing of
Association of attributes.
association of attributes.
Yes. Okay.
Attributes. So chi-square formula expected observed means expected means between that by applying that formula. So total analysis it did.
You are calculating manually. You can use that observed frequency and expected frequency.
Yes, sir. Yes, sir.
Here, it is very simple to use the chi-square test using the SPSS. No, that's why I used that procedure.
Okay, sir.
Go to analyze, go to descriptive, then cross tabs, then click statistics chi-square.
So for my thesis, I applied this already, sir. Chi-square test mostly for comparing all the 5 cities of this data.
Okay, no issues.
Okay, thank you, sir. Thank you. Thank you so much, sir. A very nice session, sir, yesterday and today. It's very pleasant. But please share this video, sir. Sometimes some net issues are there. Your voice is sometimes cutting and due to net problem. Please share the video, sir.
Okay, let us check in the forthcoming
This is Sudeep from
programs.
Mumbai. Hello.
Yes, madam.
Sudeep from Mumbai, sir.
Yes, please.
Good evening, sir, and it was a fantastic session, sir. Nice
Thank you
to
very
learn
much.
nice to learn so much from you, sir.
Thank you. Thank you very much.
Sir, I just want to have some doubt. Will you also take session for MOS or Smart PLS? And
We will arrange in future.
Art Studio, because you explained so well, because we used to tell number of times key independence, K independence sample T test, then parametric test. So I really appreciate your efforts, sir. So I find the method of your teaching, it will be very fruitful if you also teach Smart PLS, MOS, and Art Studio. Because that is the workshop where you learn your research. I feel, sir. So I keep on learning workshop because that gives me improves my knowledge. So
thank you very much, sir.
Sir, this video will be remain on for few days only, or what, which you are sending, or it will perish after 7 days.
That you can ask Dr. Sagar, sir. He will help you in
because
getting the video.
The videos remain for 5 days, and after that it perish. So
yes, recorded video will be given to you.
But that will remain for us with us, or it will it will remain for only 4-5 days.
Yes.
Okay, sir. And we'll be
sir,
getting
it is available. Don't worry.
Okay, sir. Okay. Thank you, sir. Thank you.
Thank you very much, sir.
Thank you, sir.
Hi, sir.
Hi, ma'am.
I'm Shri Divya.
Okay.
Right now, I'm doing a test in a progress test, which is like a weekly test. I'm analyzing pre and post test in the beginning, and then in the middle of a week, I'm taking a weekly test. So how can I compare that between control and the experimental group, sir?
In the case of experimental group and control group, you have to apply t-test.
Okay.
And pre-test and post-test means you have to apply paired sample t-test.
Okay. And then there are weekly tests are also there. Can I take multiple regression? I don't know what is meant by multiple regression in ANOVA. Could you please explain?
Regression is entirely different.
Okay.
That is different concept, and let us have another session in future.
Okay.
And then we will discuss about correlation, regression, and all. Okay.
Okay.
Here,
the
t-test can be used for comparing 2 groups only. I told you.
Yeah.
Suppose t-test you are conducting means that control group and first week, control group and second week, control group and third week, control group and fourth week. Like that you can compare. Or otherwise, week 1 and week 2, week 1 and week 3. Like that you can compare.
Yeah, okay. And I want to know what is different between one-way ANOVA and regression. I don't know what is meant by that. Everybody keep on saying about regression, correlation. I don't have any idea about it because I'm doing my research in English literature, and I feel
Okay.
like completely different. I don't know what is that. That's why I'm asking, sir.
Okay. See, correlation and regression are used to test the relationship between the variables. Okay.
Okay.
In the case of correlation, the degree of relationship is measured. In the case of regression, the extent of relationship is measured.
Okay.
If one variable is known and another is unknown, the unknown variable can be predicted or forecasted with the help of known variable. So that is called regression. Correlation is the measure, or the coefficient of correlation is used to measure the degree of relationship between two variables.
Okay. Okay.
For that purpose, correlation and regression is used.
Okay, sir. Thank you so much, sir. It was really nice session with you.
Thank you very much, ma'am.
Yeah, thank you, sir.
Sir, could you please provide your number, sir? If any doubt is there, we can clarify.
Yeah, it is already displayed by Dr. Sekhar, sir. My number is 98426-02131.
Okay, sir. 98426-02131.
02131. It is displayed in the chat box by Dr. Sekhar, sir.
Thank you, sir. Thank you, sir.
Thank you very much, sir.
Thank you, sir.
And sir, could you please take classes like SEM analysis and for other this regression and all? Could you please take classes for that? Because the way you're explaining is too good, very easily to understand by anyone. That is why, sir, we are asking. It was like really
Sure,
nice
ma'am.
session with you. Yeah.
You keep in touch with Dr. Sekhar, sir.
Yeah.
He will inform you the future programs also.
Thank you so much, sir. Yeah.
Thank you, ma'am.
Hello, sir.
Yes, sir.
Sir, I am Chenny Kumaran.
Yes, sir, please.
Very excellent session, sir. Today only I attended. Yesterday I missed out. And
Oh, you didn't attend yesterday? Okay.
Yes, sir. Yes, sir. And the travel.
Oh.
So when I reached my home very late.
I don't know whether you missed us or we missed you.
In the evening, around some 7:45 something, I tried it, but it is, I think, session is over.
Okay.
And today only I can attend it. Nice session, sir. It's a very the way you are expressing and give the based on the test. So many doubts are there. So far, no one has revealed clearly. So
thank you.
Excellent way you are
Thank you
explaining,
very
sir.
much. Where are you working, sir?
Still, I'm having doubts, sir. So like you were telling that.
Yeah, my number is given. You can call me privately.
Okay, sir. There's some independent test, dependent test, and
Yes, yes. Whatever you
like
doubt,
that.
any participant, please note my number. It is given in the chat box. Whenever you have a doubt, you can ask me.
Do you have any table forms, sir? Like the sample, like what type of test? Like it may be one variable, independent variable, two variable.
Yeah, let me give
one sample tool.
Yesterday,
like that, it will be more get clarity.
Sure.
Sure, sir.
I will give the table to Dr. Sekhar, sir. He will share you in the group.
Sure, sir. Sure, sir. Thanks, sir. Thanks a lot, sir. Very nice.
Any other doubt? Okay, it's time for vote of thanks. Now I would like to call upon Mr. T. Gomadi to deliver the vote of thanks.
Ladies and gentlemen, a very good evening to all. It gives me an immense pleasure to deliver the vote of thanks for this event to all dignitaries assembled here. I would like to thank our chief guest, Dr. D. Kumaresan sir, who honored this function with his inspirational thoughts. I would like to thank our beloved founder and managing trustee, faculty members, research scholars, students, and volunteers, and last but not least, our beloved audience for making this function a grand success. Once again, I thank one and all present here. Thank you. Thank you so much.
Thank you very much, madam.
Thank you, madam.
Thank you, Dr. Sekhar, sir.
Thank you, sir.
Thank you, all the participants. I wish you all the good luck.
Thank you. Thank you.